हाँ, जोर से आवाज आ रही।
A very good morning, everyone. I welcome Principal Ma'am, Dr. Nisha Bhargava, the faculty members and students to this ICPR periodic lecture organized by the Department of Philosophy, Meherchand Mahajan, DAV College for Women, Chandigarh. Thank you very much for joining us today for a discourse on the topic Our Place in Space. It is my honor and privilege to welcome our guest speaker for today, Dr. Smriti Mahajan, an observational astrophysicist, a SCRB research scientist at Indian Institute of Science Education and Research, Mohali. I would also like to extend my gratitude to Indian Council of Philosophical Research for providing us with the opportunity to organize this event. At the helm of all the fervent activities in the college is our dynamic principal, Dr. Nisha Bhargava, who is a renowned and prominent figure in the field of economics, an avid researcher, an able administrator, an eloquent speaker, and poetess. She has been the worthy recipient of numerous awards in her illustrious career. It is under her able leadership that the college continues to make strides in all avenues and endeavors. May I now request Principal Madam to welcome our guest speaker and address the young audience. Principal Ma'am. Ma'am has joined us, so I request Ma'am to address the students and welcome our guest speaker, Dr. Smriti Mahajan. I believe there's some technical issue with the audio. Just wait for a while. She'll be addressing.
Hello.
Ma'am has joined us.
Am I audible?
Yes, ma'am. Yes, ma'am.
Actually, there was a lack of communication. I didn't know that I have been already asked to speak. Thank you. Uh, Professor Smriti Mahan, our guest speaker for. Hello. Hello.
Yes, ma'am.
आ रही है मेरी audible?
Ma'am, you're audible.
Audible?
Anji, ma'am, you're audible. You're audible.
Okay. Okay then, dear Professor Smriti Mahajan, our guest speaker for today, Mrs. Suman Mahajan, head of philosophy, members, welcome you all on a full event today. The theme compels us to look within our sense and our desire is what drives religion and some in a forward direction to find an answer to the fundamental we have been pondering since the dawn of come from to and what universe. I would like to cite a quote by Immanuel Kant. Two things fill the mind with ever new and increasing admiration and awe. The oftener and the more steadily we reflect on them, the starry heavens above and the moral law to know and understand this universe and our relation to it is very important to make our existence meaningful. I am sure that our guest speaker, Dr. Smriti Mahajan, will enlighten our audience about this wonderfully engaging mystery. I will take this opportunity to express my gratitude to Mrs. Suman Mahajan and to Indian Council of Research for this paper, which has practical and spiritual. And I extend to Mrs. Mahajan valuable time for us coming to enlighten us profoundly beautiful theme.
Ma'am, for out time to raise and fueling by instilling more, which will help higher goals in life. Before today's event, I'm about the college. Mahajan DAV College is known for institution for women's education in North India since 1968. It has long stood as a strong and steadfast pillar upholding the community values of integrity and excellence of our beautiful city. The college functions under the aegis of DAV College Managing Committee, which is successfully running about 1,000 educational institutions under the able guidance of our worthy President, Dr. Poonam Suriji, Padma Shri Awardee. The college celebrated its Golden Jubilee in February 2018, and the visit of Honorable President of India, Shri Ramnath Kovind, to the college made the celebrations historic. The college was re-accredited with grade A by NAC and has also been accorded Star College status by DBT. In addition, the college is identified as mentor institution by NAC to formally induct non-accredited colleges. The college has been one of the forerunners of Swachh Bharat Abhiyan and was awarded the first rank for the cleanest residential college in country in Swachh Campus Ranking 2018 by MHRD Government of India and All India third rank in Best Citizen-led Initiatives under Swachhata Sarvekshan 2019. The college has been nominated as an institution with Swachhata Action Plan in 2020 and recognized as Vocational Education Nai Talim Experiential Learning Action Plan Institution by Mahatma Gandhi National Council of Rural Education, Ministry of Education, Government of India in 2021. The college was awarded first rank by Municipal Corporation Chandigarh under Mission Swachh Chandigarh in Swachh Sarvekshan 2022. In academics, the college students bagged 207 top 10 positions in session 2018-19 and 160 top 10 positions in 2019-2020 Punjab University semester examinations. In sports, the college has won the Punjab University General Efficiency Shield for a record number of 39 times. The college has been ranked amongst the topmost colleges of the country by leading national dailies and magazines such as India Today, The Week, and The Tribune. The list of achievements run much longer, and we do take pride in calling ourselves a part of this great institution. I now call upon Ms. Jovita, final year student and president of MCM Sophie's Club, to introduce our speaker to the audience. Jovita.
Good morning, everyone. Our guest speaker of the day, Dr. is an observational astrophysicist currently employed as an SERP research scientist at the Indian Institute of Science, Education and Research, Mohali. She has done her PhD in astrophysics from Birmingham, UK, followed by postdoctoral research at the Harvard Smithsonian Center for Astronomy, USA, of Queensland. She is a member of the astronomical profile, boasts publications, journals, and many national and international. Take to call her a field of astrophysics. Besides research, she enjoys reading, photography, and gardening. Matter of great pride us to have you here. Academic event for making time for a busy schedule. I invite you to address the audience. Over to you. Over to you, ma'am. Dr. Samriti Mahajan, ma'am.
Okay. Thank you. I think there was some lag in the audio. All right. Thank you very much to all of you. I first of all would like to express my heartfelt gratitude to MCM, DAV, and especially Principal Dr. Bhargav and also Dr. Mahajan and all other faculty and students for joining in on this very hot Monday morning. Let me just share my screen first. Right. I believe you are all able to see my screen.
Yes, Dr. Smriti.
Okay. Thank you very much. So what we are going to do today here, what I'm going to do is give you some perspective of where we believe we are in the universe, and I will try my best to do this without going into the ugly mathematical details of the subject, which are of course required. But I mean, a question like this, that, you know, where we are in the universe, where we are in the space, you might think should be very, very trivial and should already has been answered by now, given our technological advancements in especially the last century. But you know, what I want to impress upon you to begin with is that it's not a trivial question, and it's still a simple question like this is still a very hot topic of research in this field. Essentially, I mean, you would wonder that, you know, we've been taught even in the, you know, from our school textbooks that, you know, we live on a planet called Earth. Earth goes around the sun, and the sun, you know, is one of the many stars in a galaxy. So what is this new thing that we are going to discuss today? And you'll be surprised to know that, you know, a lot of what I'm going to talk about today, especially in the second half of the talk, is the information, you know, respective to our perspective, our neighborhood, the understanding of our neighborhood in the cosmos, in the space, is what we have acquired only in the last 3 to 4 decades. I mean, think about it. 300 to 400 years ago, people were just still debating whether the sun or the earth is the center of the universe, you know, whether the sun goes around the earth or is it the other way around. Where are we going to land up if we start sailing on the sea, right? 100 years ago, you know, we didn't knew whether it's just the stars that we are seeing in the sky which makes up the entire universe, or is there something beyond those stars, etc. Okay, so geography, just like geography is the understanding of our position relative to the other land masses, to the other features on Earth, now we are getting into the regime of cosmography, which is understanding where we are relative to the larger universe. And that is what I'm going to give you a slight taste of in the next few minutes. So our very first rendezvous with the sky is something like this. Maybe, you know, even before we can memorize the infamous Twinkle, Twinkle, Little Star. But as we grow up, our perspective of the sky changes. To most of us, from a good sight, the sky would appear something like this. And by good sight, I mean a place where, you know, there is, of course, there has to be no or very little cloud cover, so you can actually see the stars. But also there has to be very less light on the ground, again, which is again something which blocks the faint light coming from the objects in the sky. Okay, so we are very close to the Himalayas. And if you go into slightly higher altitude, not to the touristic spot, but in a secluded spot, you know, slightly up in the Himalayas, you will see a very clear sky with hundreds of stars shining directly above. And for a very long time, we believed this is what the universe comprised of. And that's because everyone I have ever met in my life has, at some point in their life, thought about the star. And the reason for that is that it's free. Astronomy is free, and that's why it's so endearing and it's so exciting as a subject of study. Not very long ago, if you imagine, when there was, you know, no internet or no television, and that was the case not very long ago. People had nothing to do after dark. Once their day job was over, all that was left was to, you know, stare at the dark night skies. And that's why no wonder there are so many stories about the night sky, about the objects in the night sky, and there are so many legends amongst the different civilizations across the globe. But the thing is that this is how the sky appears to the naked eye. What happens? Now, every point of light that you see in this image is a star in our own galaxy, okay? But if I stare now at this very tiny patch of the sky, which to the naked eye appears almost empty, this is what comes to face if this small, tiny patch is looked at through the Hubble Space Telescope. So we already have very powerful telescopes which are changing our perspective of the night sky. And this has happened only in the last few decades. I mean, the Hubble Space Telescope was built in the late 80s. It was sent into the orbit in the 1990s. And this image was obtained even later than that. So our perspective of how the sky looks changes completely. Every point of light that you see up here is a star. Every point of light that you see in this image is a galaxy, okay? Except for two objects, one which is here and the other which here, which have these tiny spikes, if you could see them, right? And each of these galaxies, each of these tiny points of light or bigger blobs that you see in all different colors are galaxies, some having thousands of crores of stars, some having lakhs of crores of stars in them, right? So our perspective plays a very important role in our understanding of the universe. Talking about the perspective, I should actually have mentioned that this image that you saw on the very first slide is again giving you an idea of how the universe or our understanding of the universe can vary depending upon our perspective. So this is the image of the Earth rising in the sky of the moon taken by the lunar orbiter, just like the moon rises in the sky of the Earth. Okay. Now, two people who've played very important role in our understanding of how big the universe is and what our place in the universe is are these two characters, William Herschel. Now, William Herschel was not even an astronomer. William Herschel was famous for something completely different, and I'm sure some of you would know. He was the discoverer of the planet Uranus. But that's not why we are talking about him today. Why we are talking about him today was that William Herschel, in his backyard, built the world's largest telescope of the time, what he called the 40-foot. His hobby was to build, large telescope. By his day job, he was an organ player in the church, so he was a musician, right? And he got interested in these things that he saw in the sky, which he said was they looked like stars, but they were not really stars. And these were like small, fuzzy, cloudy things, and he called them nebulae. Now these nebulae were all kinds of different things, but to Herschel, they all looked like fuzzy, blobby things, which were not like points of light what he was expecting if they were stars. The other character is Charles Messier, who was an astronomer to the King of France. And around the same time, he ended up looking at similar objects, but for a completely different reason. Now, Messier was interested in studying comets. And although people are superstitious nowadays also, back then, in the 17th, 18th century, people were very, very superstitious. And especially when it came to comets, the king wanted to make sure that he was ready to protect his kingdom if ever a comet approached the kingdom of France. So he asked Charles Messier to create a list of all the fuzzy-looking objects. Now, comet, as you would know, most of the time they look like an inverted ice cream cone. If you think about it, it has a ball or a circular head followed by a little tail. So on the sky, from their basic equipment of the time, these things looked fuzzy as well. So Messier was looking at fuzzy-looking things which were moving in the sky or which were not moving in the sky, but they were not stars. They were something else, and both of these people did not understand those. And because of the geographical proximity in the sky. Now, the kind of things that went into their curiosity. Now, the images that you see on the screen right now are images taken with modern day telescopes. Okay, but to Messier and to Herschel, all of these objects look like little fuzzy things from their telescope. So what are these things? These are things like star clusters. Star clusters are gravitationally bound systems of stars having, a few thousands of stars in them. Then there are supernova remnants. What is supernova? Supernova is a star which has gone, which has ended its life. So a star which has died, and as it dies in an explosion, it loses all its matter, which flows out and will ultimately merge with the surrounding medium. So there were supernovae like that. And then there were also planetary nebulae. Planetary nebulae is again a single star, a star which is not died yet, but is on the verge of dying. And just before massive stars die, it so happens that they attain the stage where all of their material, or most of their material that they have, starts blowing out in very fast winds. So that is what is happening here. But most of the fuzzy things, most of the nebulae which were present in the catalogues of Herschel and Messier were what we now call galaxies. Okay? So galaxies are, of course, as I told you, thousands or lakhs of crores of stars contained in one single system. So a few thousand stars, single star, more than a million stars, more than a billion stars. All of these objects looked the same to Messier and Herschel, not just because their instruments were very, very basic, but also because, as even if the things which are closer, now the single stars were most likely in our own galaxy, whereas the other objects like the galaxies are, of course, outside our galaxy, but they all have the same size and roughly the same brightness on the sky. I mean, think about the sun and the moon. The sun and the moon appear roughly the same size on the sky, but that doesn't mean that they are actually the same size. In fact, moon is about 1,000 times smaller than the sun, but moon is also 1,000 times closer than the sun. As a result of which, when we look up at the sky, their relative size looks about the same. And that is exactly why the Herschel or the Messier catalogue had all of these different kinds of objects in their list. Now, I also wanted to put up this picture up here for two reasons. So Herschel, as I told you, William Herschel built the world's largest telescope of the times, which he called the 40-foot, which translates basically to a 12-meter telescope right in his backyard in England. And before that, he had built the 20-foot telescope. And this before he became famous and he got a lot of money from the king to discover Uranus. Okay. Now, his son, John Herschel, also was a very talented, very esteemed astronomer in his own right. He ended up discovering a number of moons of Uranus and Saturn. But one of the most important things that he did in his lifetime is that he took his father's telescope to the southern hemisphere, to South Africa, in Cape Town, and he started exploring the skies in the southern hemisphere. Now, most of the people in the 17th and the 18th century who were doing astronomy were based in the northern hemisphere. And in the northern hemisphere, the sky is very different from what it is in the southern hemisphere, and I'll tell you that. I'll come back to that point in a minute. So William Herschel, when he first started making his list of these fuzzy objects, he had a little over 100 or so objects. John Herschel ended up extending this list to more than around 2,500 objects. But another very interesting character in the Herschel family is Caroline Herschel. Now, William Herschel lived in his house with his sister Caroline, and initially the Caroline's diary is now published, and Caroline writes in her diary that, my brother is completely crazy. He has, glass and metal sheets strewn upon, everywhere in the house, and he, during the day it's fine, he goes to the church and he plays his organ, but at the night he's doing all these crazy stuff, and I trip over this metal sheets which he's strewn everywhere, and I don't know what nonsense he's doing in his backyard. But what happens is that as William Herschel becomes more and more famous and he earns all this money, he's becoming busier and busier during the day. So he actually has just built the telescope, but he has no time to use it. Who ends up using the telescope is Caroline, because she slowly becomes interested in astronomy, and she ended up discovering 8 comets on her own. Okay, her brother didn't discover anything. He didn't discover any comet which were of very, which aroused a lot of public interest, as well as the interest of the king, and so on during the time. But she became very famous as well from their family using her brother's telescope. So the next milestone in our understanding of our place in space is that, we know already that we live on this planet Earth, which is going around a star called Sun. And the Sun is a part of a galaxy called the Milky Way. Okay? But Sun is no special star. It's not even at the center. It's actually 8 kiloparsec away somewhere in the disk. So the Milky Way is like, is in a planar object. In a plane, it's like, a flat chapati. And at the center, it has this bulge, just like, the bulge starts building up when the chapati is just about to puff up. And that's exactly what the shape or the morphology of our galaxy, the Milky Way, is. But this is not, of course, a scientific image, because we have not yet left the galaxy to, take a selfie with it. But this is a scientific reconstruction of what we believe our galaxy would look like if we would ever leave the galaxy and take a picture of it. And this is based on our observations of other spiral galaxies, as well as our observations of our own galaxy, which we have made from our position inside the galaxy. Now, because the Sun is part of the disk of the Milky Way, you can imagine that if you look along the disk, you will see a lot of dust, and dust blocks light. So in that direction, where you see the dust, you will not be seeing many objects. But if you look up or down, which we can, depending upon our position on Earth. So the part of the sky which is, observable from Australia is very different from what is observable from India, which is in turn very different from what is observable from Chile or from the United States of America. So from different countries or different places on Earth, we can observe different parts of the sky. But what I want to impress upon you is that in one direction, along the disk, if we will see a lot of this dust. Now you may ask, where is this dust coming from? Now this dust is just the leftover material. When you roll the chapati, you have a lot of flour which is scattered around as well, right? So that is exactly what has happened here. The stars have formed in the galaxy out of hydrogen gas, but there is a lot of other material which is left over from from the material that the stars have formed. So there is hydrogen, there is carbon particles, etc., which is what we are calling as dust. And all of this, because their temperature is not very high, is coming together and building up larger particles, larger molecules. So the Sun, which will be somewhere here if we were to look at the Milky Way from the top, is going around slowly around the galaxy. Okay? The Sun, the Milky Way itself is rotating. In fact, when I say slowly, that means the Sun is going around with a speed of about 220 kilometers per second. But on the cosmic scale, that's a very slow speed. And the Sun, during its lifetime of about 4.5 billion years, has already gone around the center of the galaxy about 20 times. Right? Now, I told you that if you look in one particular direction along the disk, you will see a lot of dust, and that is exactly what we see. So this is how the sky appears to the naked eye from a good site. So this particular image is taken from your standard camera on the island of La Palma in Spain. So this is how this dark band appears. In fact, if we had lesser light pollution in the Tri-City, part of the Milky Way band should be visible from the Tri-City. But unfortunately, that's very rare, and that requires a very powerful instrument and very selective sites around us from which that is possible. But the more you go towards the equator and then to the southern hemisphere, the more likely one is to see the Milky Way in all its glory from a good side. Now, I also told you that the sky in the southern hemisphere is very different from the sky in the northern hemisphere, and that's because of these two little objects. Now, this image is taken at the CTIO observatory, which is in northern Chile, and you see these two blobs. Just through the naked eye, one can see them. And these are the two moon galaxies. I call them moon because moons are satellite that goes around the planets. And then there are these little satellite galaxies which go around the bigger galaxies to which they are gravitationally bound. So these are two moon galaxies of the Milky Way. These are called the Magellanic Clouds, named after a sailor called Magellan. So Magellan was sailing, and as he was sailing through the Cape of Good Hope around South Africa, he documented that there are these two fuzzy clouds in the sky, which are spread over the Milky Way, are named after him as the Magellanic Clouds, large Magellanic Cloud and the small Magellanic Cloud.
Dr. Smriti, I believe something's gone wrong with your connection.
Okay, but all of this we knew or started understanding at the turn of the 20th century. It is new when you
All the participants are requested to stay in the webinar. Maybe there was some connectivity problem. Our speaker would be joining us in a while. all the students are requested to stay in the event. Maybe there's some technical glitch, so be patient and bear with us.
The students are not supposed to leave. You're supposed to stay back. So please stay here. Thank you so much. I can already see people leaving. The event has not ended yet, so you're requested to stay back. I once again repeat that you're not supposed to leave. You have to stay back for a while. We have just sent a feedback form. Everybody is supposed to fill it up, so please fill it up right now. I hope I'm audible.
Yes, Jovita, you are audible.
Okay, ma'am. You can all leave by 12. Till then, please wait. Please be patient for 5 minutes at least. And if our speaker doesn't join us back by 12, you all can leave. Okay, I guess our speaker won't be able to join. You all can leave. Thank you so much for joining us.
Maybe we can, continue with the part which we had left in some other lecture.
Yeah,
Thank you, everyone, for joining us. Thank you so much.
thank you. अब क्यों ज्वाइन कर रहे हैं?
Fill the feedback form.